So in this part, now we are going to discuss, the distributed parametric model type of the problem.
Excuse me, sir.
Yes,
सर इससे एक पहले स्लाइड ये वाली अभी
ये
यस सर ये
ये हो गया ना?
यस सर
Okay. So now we are going to discuss the distributed parametric model. So in the distributed parametric model, you have to first understand what is the difference between the lumped and distributed parametric model. So lumped and distributed parametric model is, you know, defined based on their characteristic of the distribution. Simple. In the lumped case, we just imagine that we assume that the object is the point object. The object is the point object we are just considering. However, in the case of distributed parametric model, we are going to microscopic study of that object. That object is not a point object right now in this case of the distributed parametric model. Okay, and also you can say that in the lumped parametric model, the model only depends on the time, function of the time only. However, in the case of the distributed parametric model, the model is not only depends on the time, also depends on the space. It is maybe the three-dimensional, it may be the two-dimensional, maybe the one-dimensional, maybe the multi-dimensional. I have only taken here the xt. It may be the x comma y comma t. It may be the x comma y comma z comma t. Right. So it becomes the problem of the transport phenomena. It becomes the problem of the transport phenomena, right? Transport phenomena. So when distributed parametric model of the problem will come into the picture, then you are going to, the tool will come. You can see when the model is going to develop with the help of the distributed parametric model, then the model is based on, the parameter, the partial differential equation PD. Because why PD? Because it is the del by dt of, also, the temperature is not only depends on the time. This temperature depends on the x value also, the, dimension also. You can see the example. Let's say we have a one conductor. We have one conductor and we want to find out the temperature distribution, right? Temperature distribution with the length. Okay, so the temperature is not uniform in this conductor. Okay, so that is temperature is not only depends on the time, t is equals to 0, t is equals to something. Okay, but also depend on this x variable, length also. The temperature of this point and this point and this point is not same. Yes or no? Yes or no? Am I
यस
audible?
सर
Okay. So therefore, this the problem becomes the distributed parametric model problem. Distributed parametric model problem. Okay. Okay. Now, and the lumped parametric model is a simple differential equation d by dt. However, in the case of distributed parametric model, the model will generally give the PD, partial differential equation. Okay. So in the mathematics, we will discuss 2 to 3 problem based on this, distributed parametric model, how to solve the type of the differential equation or the partial differential equation, right? Okay. So here is the problem that I have taken the very simple problem, the, heat conduction in a solid. The flow of heat by conduction follow the Fourier law, as you know that the temperature, as the length increases, the temperature will decreases. Yes or no? As the temperature as the length increases, the temperature will decreases, and therefore you can write the minus of del t by del x, minus of del t by del x, and with some constant. This is the constant is the thermal conductivity. K is the thermal conductivity. Del t by del x is the temperature gradient, the distribution of the temperature with respect to the x. Okay, and Q is the heat flux. So whatever the heat is going to the flux in the form of the flux, right? Is it any problem?
नो सर
Okay. So
No,
now
sir.
come to the next. So you can say here whatever the flow of heat, the concept will remain same. Distributed parametric model, the concept will remain same. Whatever the in minus out is equals to some accumulation. Simple. Fundamental is same. In minus out is equals to एक्यूमुलेशन. तो व्हाट इज गोइंग टू इन इज इन द क्यू. यही तो इन हो रहा है, हीट ही तो इन हो रहा है और हीट ही आउट हो रहा है. तो हम इसको लिखेंगे क्या, K इंटू डेल टी बाई डेल एक्स, के क्यू इंटू इस एरिया में कितना एरिया है इसका, एरिया इज ए, द क्रॉस सेक्शन एरिया ऑफ दिस, द क्रॉस सेक्शन एरिया ऑफ दिस स्लैब इज लेट्स ए. सो इस एरिया में, इस पूरे एरिया में कितना आपका हीट इंटर हो रहा है, तो इतना K इंटू डेल टी बाई डेल एक्स, राइट. एंड इस पॉइंट पे कितना होगा, तो यू कैन राइट सेम माइनस ऑफ माइनस, अगर सपोज कर इन यहां हो रहा है आउट यहां हो रहा है, तो हम लिख सकते हैं क्या, ए इंटू के डेल टी बाई डेल एक्स, एक्स प्लस डेल एक्स एट एक्स प्लस डेल एक्स. एम आई राइट, यस और नो. यहां तक कोई प्रॉब्लम है, इन माइनस आउट, वाट एवर द हीट इज एंटरिंग मल्टीप्लाइड विद द ए एरिया, तो कितना बन गया, इस एरिया में कितना हीट इंटर हुआ, एक्स प्लस डेल एक्स के जगह पर हम इसको मल्टीप्लाई करेंगे किससे, इस के वाले डेल टी बाई डेल एक्स क्यू से, इस एरिया से कितना निकला, यही तो है इन माइनस आउट. इज इट क्लियर?
Yes, sir.
And what is the accumulation? Accumulation is always done in the temperature. So you can del T by T is the term of T minus TR reference. और इसको आप बैलेंस करने के लिए क्या किया आपने, हीट को आप इसके साथ मल्टीप्लेशन किए. A इंटू डेल एक्स क्या है तुम्हारा, व्हाट इज द A इंटू डेल एक्स, डेल एक्स इज द A इंटू डेल एक्स इज द वॉल्यूम,
Value.
डेंसिटी इंटू डेंसिटी इज इक्वल टू मास अपॉन वॉल्यूम, वॉल्यूम वॉल्यूम कैंसिल, यस और नो, केजी पर आर, kg per r degree Celsius. So S of multi degree Celsius cancel. Simple kilojoule per the per time per r will come in the picture, right? So ये आपका फंडामेंटल है. अब हम आते हैं आगे की बात करते हैं. अब हम इसके आगे की बात करें, आगे अब ये तो मॉडल बन गया, ऑर्डर मॉडल आपका. नाउ वी हैव रिटन द इक्वेशन. नाउ योर ड्यूटी इज टू सॉल्व दिस इक्वेशन. नाउ अब क्या सॉल्व करेंगे, देखो जरा. इफ दिस इज x दिस इज इफ x प्लस डेल x, ओके, x प्लस डेल x, और ये क्या है, अगर हम इस डेल x से जस्ट डिवाइड कर दो, एरिया से डिवाइड कर दो, a इंटू डेल x, तो इट विल बिकम a के a विल कैंसिल टू इच अदर, a विल कैंसिल टू इच अदर, a आप कैंसिल कर दो, राइट. सो व्हाट विल कम, it will come k delta t by del x minus of k delta t del x, x plus delta x, x plus delta x minus minus plus, राइट. तो पहले ये लिखा माइनस ऑफ दिस डिवाइडेड बाय दिस डेल्टा एक्स इक्वल टू 0 डेल बाय डेल ऑफ डेल टी बाय टी आर माइनस टी आर. इट इज राइट, इट इज करेक्ट, यस और नो?
Yes, sir.
Okay.
Yes, sir.
Now what is
Yes,
this? If you write fx plus delta x minus of fx divided by del x if limit delta x tends to 0, what is this?
differentiation.
Huh? Sorry, what is this? ये है क्या? This is nothing but the d by dx of fx.
Differentiation.
Yes or no? Yes or no? So this is the
Yes,
first
sir.
derivative. In similar way you can write here. ध्यान से देखो जरा, ये है क्या? x plus delta x minus of this is fx plus delta x minus of fx divided by del x. If this delta x limit tends to 0, if delta x is very very small, then you can write that this is nothing but the derivative of this function k delta 2 by del x square. Yes or no? That's the function. And here this is the del rho c t by t, because if you take the reference temperature in value 0 or you define the deviation variable, ठीक है, तो ये आपका बन गया इस तरीके से. Am I right? Any problem? So you can see here the k delta 2 t by del x square, ये क्या है आपका, t is dependent on the x and rho c temperature depend on the time, okay. And when k by rho c is defined as a constant, k by, यहाँ पर आप इसको k by rho c ले लीजिए, so it will cancel, so it will come alpha delta 2t by del x square is equals to del t by del t. So this is the partial differential equation. Now you have to solve, simple. And if you are able to solve, then the transfer function whatever you will come, the length at 0, मतलब क्या हुआ, L से temperature at this point, temperature at this point in the Laplace transform you have defined, and this this transfer function is coming in the form of like this. And how you are going to solve, just see how you are going to solve this problem. See, हमने क्या किया कि ये जो प्रॉब्लम है दैट इज द अल्फा del 2 by del x square is equals to, you have defined del t by del x, sorry, del t by del t. We have just integrate, or we have just defined, let's say this is ft or some function. Okay, so how we implement the Laplace transform in this function? Can you tell me what is the Laplace? Laplace के लिए क्या करना होगा? 0 to infinite ft e to the power minus st dt, yes or no? This is the Laplace transform. This is the definition of the Laplace of ft, yes or no?
Yes.
Yes.
So this is, let's say, the ft. This is the, let's say, the ft. Now you are going to integrate from 0 to infinite. You have taken the Laplace 0 to infinite e to the power minus st dt, 0 to infinite e to the power minus st dt. So this is the nothing but you have defined, just you have taken the Laplace of this, the equation, the Laplace of this equation, right? This equation. Okay, so first हमने इसको solve करते हैं. पहले just try to solve this equation, and then we will take the RHS. Okay, so 0 to infinite del 2 by del x square xt e to the power minus st dt is nothing but del by del, इसको हमने बाहर ले लिया, this function. Okay, and we have taken txt to the power minus st dt. Okay, और जरा बताइए 0 to infinite ft e to the power minus st dt is what is this? This is, you can write fs. You can write fs. Yes or no? Yes or no? Yes or no? 0 to t ft dt e to the power minus st dt. What is
Yes, sir.
this? This is fs.
Yes.
So
FS.
simply you can write ts. अरे ये जो आपका टर्म है वो उसको लिख सकता है ts.
Yes, sir.
So we have written ts like this, t bar sx, so that there is no confusion between the t and t bar, because this is representing the Laplace operator. Okay, t, so here it becomes d2 by dx square txs, क्योंकि ये आपका d बार है, ये इसको हमने ले लिया यहाँ पर. ओके, अब नाउ राइट हैंड साइड को देखो. राइट हैंड साइड इज आल्सो del t by del x square e to the power minus st, just to define with the initial condition sts minus tx 0. ठीक है, तो आपने दोनों कंडीशन में इसका आपने लिख लिया यहां पर, दिस टर्म इज हेयर एंड दिस टर्म इज हेयर. ओके, जस्ट टू इक्वेट, ट्राई टू इक्वेट. तो व्हाट इज द इनिशियल कंडीशन? What is the initial condition? Tx 0. What is it meaning? At t equal to 0, what is the temperature at x? So t is equals to 0. At t is equals to 0, what is the temperature? So let us consider 0. Let us consider from some time it is 0. So just put this value. Okay, तो ये हो गया 0. इसका लाप्लास ये लिख लिया आपने, del 2 by ds square is equals to s by alpha t. और this becomes simple है. Now what? Differential equation. It becomes a simple differential equation. समझ में आ रहा है या नहीं आ रहा है? Yes or no? This is simple a differential equation, second order differential equation, linear differential equation. The solution of such type of differential equation is given like this: a1 e to the power minus root under s by alpha x, a2 e to the power minus s by alpha x. Okay, so you have defined the value of, try to find out the value of a1 and a2 है ना. तो इनिशियल कंडीशन हमको पता है, जस्ट पुट दिस वैल्यू एंड you will see the transfer function of the such type of problem will come e to the power minus, because this will become 0. आपको कि आप x is equals to 0 पुट करोगे, ये आपको मिलेगा. x is equals to infinite पुट करोगे, 0 मिलेगा. 0 हो जाएगा तो ये आपका 0 हो गया, ये टर्म मिलेगा. दैट इज द ट्रांसफर फंक्शन. सिंपल. ओके, सो by this way you can you can find out the transfer function for the distributed type of the model, and it is one of the easiest problem we have.